This is Steve Piloff from George Mason University. Go through a few examples of the present value of delayed perpetuities and annuities. So we want to know what the present value of the big lotteries payments are. If it'll pay out $1,000,000 per year forever with the first payment in 3 years. So in 3 years, it's going to pay out $1,000,000. Then in 4 years, $1,000,000, 5 years, $1,000,000, forever and ever and ever and ever. Well, this looks kind of like a fixed perpetuity, except in the sense that it's $1,000,000 every year forever and ever. But if it was a fixed perpetuity, then the first payment would be here in 1 year, but that's not the case. It happens later, so this is a delayed perpetuity. So what we want to do is take our time machine and we go to time 2, which is 1 period before the first payment, and we say, aha, we get out and look, what do we see? We see that in 1 year we'll get $1,000,000, next year we'll get $1,000,000, and then $1,000,000 forever and ever and ever. So as of time 2, this thing looks just like a fixed perpetuity because the next payment is in 1 year. So in 2 years, the value of our winning lottery ticket would be $25 million. So really the question is, we have a winning lottery ticket. It's going to pay us $1,000,000 in 3 years, $1,000,000 in 4, $1,000,000 in 5, $1,000,000 in 6, forever and ever. Discount rate's 4%. How much is that lottery ticket worth? Well, in 2 years, that lottery ticket will be worth $25 million. What we want to know is what it's worth today. And that is simply 25 million over 1.04 squared. If we know it's worth 25 million here, then you just discount it twice, and the answer is 23.1 million. That is what the value is of our winning ticket today. So again, there you can see the present value at time 2 is 25 million. 25 million in 2 years is worth 23.1 today, and that's the price of the ticket. So at a discount rate of 4%, you're indifferent between getting 23.1 million today, getting 25 million in 2 years, and getting $1,000,000 per year forever, starting in 3 years. So 3, 4, 5, forever and ever. All three of those things have the same value. We've got a building. Let's get some red here. Expected to pay out cash flow of $1,000,000 in 4 years. Then after that, cash flows forever that increase by 2% a year. So 1 million to 1.02 to 1.0404, forever and ever at 2%. Cost of capital is 4%. And we want to know what the value of the building is. How much is it worth here at time 0? Well, this looks like a growing perpetuity in the sense that you've got your first cash flow, and then after that all the ones are 2% higher. But it's not a perpetuity, because if it was a perpetuity, then the first cash flow would be here, and it's not. It's here. So let's get into our time machine. Make sure we go to the point in time that's 1 period before the first payment. We get out, and we say, aha, look. In 1 period, it's $1,000,000. And then after that, all the cash flows grow by 2%. Well, that is a growing perpetuity. So the present value in 3 years is 1 million over 0.04 minus 0.02 is $50 million. It's just equal to the next cash flow over R minus G. So we know that this building is expected to be worth $50 million in 3 years. Well, how much is expected to be worth today? Because that's what the question is. Well, something that's worth $50 million in 3 years is worth $50 million over 1.04 to the 1, 2, 3. So the value today is $50 million over 1.04 to the third, which makes the building equal to $44.4 million today. So again, in 3 years, the building is expected to be worth $50 million. Something that's expected to be worth $50 million 3 years from now is expected to be worth $44.4 million today. And so again, you are indifferent between getting $44.4 million today or the value of 44.4 million today is the same as the value of 50 million in 3 years, which is the same as cash flows that go on forever and ever and ever if they start in 4 years at 1 million and then grow by 2% per year after that. Last example, we have the little lottery, and we just won. We want to know what the value of our ticket is. Equal annual installments of 10,000 with the first payment in 5 years and the last payment in 9 years. So we're going to get 10,000 in 5 years and the last 10,000 in 9, and these are annual installments, so we know we'll get 6, 7, and 8, 10, 10, and 10. So that looks like a delayed annuity. We've got a finite number of fixed cash flows that start after time 1. So get into our time machine and jump out to the period in time 1 before the first cash flow. So we get out here at time 4, and what do we say? Aha, look, in 1 period of cash flow, 2 periods of cash flow, 3, 4, and 5. And we can count. We get 1, 2, 3, 4, 5 cash flows. And so that from that point in time, we can value these as an annuity, where n is equal to 5, payments equal to 10,000, FE is 0 because there's no extra special cash flow at the end. I percent is equal to 5 because the discount rate is 5. And we would be in end mode because we're setting it up so the next payment's in 1 period. And if we go ahead and do that, which is the same as doing 10,000 over 1.05 plus 10 over 1.05 squared plus 10 over 1.05 to the third plus 10 over 1.05 to the fourth plus 10 over 1.05 to the fifth, in 4 years from now, our lottery ticket is expected to be worth $43,295. But that's what it's expected to be in 4 years. We want to know what it's worth today. Well, the answer to that is just 43,295 divided by 1.05 to the first, second, third, and fourth. So something that's worth 43,295 in 4 years is worth how much today? 35,619. So our lottery ticket, which is going to give us 10,000 in 5, 6, 7, 8, and 9 years, today is worth 35,619 if the discount rate's 5%. And so you can see here, financial calculator with those 5 payments gets us the value of 43,295. And since the payments start at time 5, we're going to go to time 4. And something that's worth this in 4 years will be worth 35,619 today because we're dividing by 1.05 to the fourth. And again, we've established that when the discount rate is 5%, 35,619 today has the same present value as 43,295 in 4 years, which has the same present value as 10,005, 10,006, 10,007, 10,008, and 10,009. And again, the reason we got 5 payments is because we counted them. We were told when they started and when they ended, 5, 6, 7, 8, 9.